Imagine you have four services running: Postgres, Redis, your API, and a worker. You change one thing, just the log level on the API, and you run Docker Compose up again. The API restarts, everything else keeps running, same containers, same uptime. Compose somehow knows the other three do not need touching. It is not guessing, and it is not checking timestamps. It has a very specific way of deciding whether a container still matches what is in your Compose file. So how does it know? That is what we are going to look at. Open a Compose file and it is easy to read it like a shell script. First Postgres starts, then Redis, then the API, then the worker. That is probably how most people understand one the first time they see it, and it is a reasonable guess given how the file is laid out. Compose never reads it that way. It treats the file as a description of a system that should exist, listing the services, the images behind them, the network they share, and the volumes that outlive them. Two things are missing from that file. It never says what order to start things in, and it never says what to do about containers that are already there. Compose answers both by comparing the file to what is already running. Before any of the clever parts, it is worth reading one of these files properly, because every line is answering a specific question. The top-level key services introduces the things that will become containers, and each name under it, DB, cache, API, worker, becomes one. Under DB, image name's a pre-built thing to download, Postgres version 16, and that is the whole definition of that container. Under API, you get build dot instead, which says, there is no pre-built image, construct one from the Docker file in this directory. Those two keys are answering the same question: where does the image come from? And a service uses one or the other, never both. Four more keys carry most of the confusion. Ports maps a port on your machine to a port inside the container, written host : container. So 8080:8080 is your laptop's 8080 reaching the containers. Environment sets variables inside the container, which is where log level lives. Volumes under a service mount storage into it, and the name on the left of that colon refers to a volume declared at the bottom of the file, which is why volumes appears twice at two different levels. And depends on names, another service that should come up first. Every one of those is a fact about one container, written down, and none of them is an instruction to do anything. Before any of that, Compose has to work out what the file even says. The file you wrote is rarely the file it uses. It reads compose.yaml, then quietly layers a compose override file on top if one is sitting next to it, and anything you pass with the file flag stacks in the order you passed it. Later files win, key by key. Lists behave differently, and this is where the surprises come from. A list in a later file replaces the whole list from the earlier one. If the base file gives the API 2 ports and your override name's 1, you end up with that 1 port and the original 2 are gone. Variables resolve at this stage too, out of your shell or a .env file. To see what actually came out, Compose config prints the merge document with every variable filled in, and it is the fastest way to end an argument with yourself. The merge document still describes nothing in particular until Compose gives it a name. That name is the project, and by default it is just the directory you are standing in. Every object it creates carries that name, plus a label recording which service it belongs to, so the API container is stamped with this project and the service name API. That stamp is how Compose knows what it owns. It never scans your machine looking for containers that seem about right. It asks the engine for everything carrying this project label, and that list is the only system it knows about. Two copies of the same file in two directories run as two systems that cannot see each other. Rename the directory and Compose loses the API completely, because as far as it is concerned, that project never existed. Here is how it decides. For each service, Compose asks the engine what already exists under this project label. If nothing is there, it creates it. If it finds an existing API container, it has one question to answer. Does this still match the Compose file? You might imagine it comparing every field one by one, walking the image, the environment, the ports, the mounts. It does not. When Compose creates a container, it takes the entire resolved configuration for that service, hashes it, and writes the hash onto the container as a label. On the next run, it recomputes that hash from the merged file and compares two strings. Match, and the container is left completely alone. Different, and it is stopped, removed, and created again. One string comparison per service. That is the whole decision. That comparison is also what makes up safe to run over and over. On a system that already matches the file, every hash matches. Nothing has drifted, and compose does nothing at all. Worth sitting with, because it changes how you use the tool. Most people reach for up once, at the start. It belongs after every single edit you make to that file. Restart is what most people reach for instead, and it does something narrower than it sounds. It stops and starts the same container with the configuration it already has. So you change the API's environment variable, run restart, and the old value is still there, with nothing in the output explaining why. Restart is for kicking a wedged process. Up is for making the running system agree with the file. There is not one word about networking in a basic compose file, and yet the API reaches Postgres at the hostname DB. So where did that name come from? Compose created a network for the project without being asked and attached all 4 services. On that network, the engine runs a DNS resolver, and every service name is a host name in it, so DB resolves to the DB container's address. That resolver only answers inside the project, so from your laptop the name DB means nothing because your laptop was never attached to that network. This is what people conflate with ports. Publishing a port opens a door from your laptop into one container. The API talking to DB never uses that door. It goes over the project network, straight to the container's own port. So deleting the ports list never breaks the API's connection to the database, and adding one never repairs it. Ordering is where the model gets tested. Depends on gives you an order, and the order is weaker than it looks. It waits for the container to be started, meaning the process exists. That is all it means. Postgres takes a few seconds after its process starts before it will accept a connection. So the API starts inside that window, fails to connect, and exits. The file said the API depended on the database, and the database was running, technically. What is missing is a definition of ready, and a health check is how you write one down. It runs a command inside the container on an interval, and the container is healthy once that command succeeds. Then depends on can ask for condition service healthy, and compose genuinely waits. Started as a fact about a process. Healthy is a fact about your application. Containers under compose are disposable, and the recreate step throws away everything written inside one. Every time the API's hash changed in this video, its file system went with it. Named volumes are the exception, and they are why your database survives all of this. A volume is created once, mounted in, and left alone when the container around it is destroyed, so Postgres can be recreated 50 times and keep its data. This is also what quietly confuses people at cleanup time. Down removes containers in the network and leaves named volumes exactly where they are, which is a deliberate refusal to delete your data just because you stopped a stack. That database, with the schema from 3 migrations ago, is still sitting there, still mounted on the next up. Removing it takes down with the volumes flag, and you have to mean it. A service points at an image or at a build context, and those two behave differently in a way that matters here. An image is pulled once and cached, and Compose will not go hunting for a newer version of a tag on its own. A build context gets turned into an image locally, and the config hash covers the build settings, not the contents of your source tree. So you edit the API's code, run up, and nothing happens. From Compose's point of view, the description did not change. The image reference is identical, the hash matches. It is behaving exactly as designed, and it feels broken. The rebuild has to be asked for, with up in the build flag, or by building first. The comparison is between the file and the running system, and your source code was never part of it. At the bottom of all this, Compose is making ordinary API calls to the same engine you would talk to by hand. Create a network, create a volume, then one container create per service, each carrying its image, its command, its environment, its mounts, its network attachment, and those labels recording the project, the service, and the config hash. There is no Compose runtime living alongside your containers, no agent, no daemon of its own. It converges, exits, and the labels are the only memory it leaves behind. 2 consequences fall out of that. A container you started by hand has none of those labels, so Compose cannot see it and never touches it. And if you delete the API from the file, its container keeps running, because Compose only compares services the file still mentions. That container is an orphan now. Compose reports it on the next up, and leaves it alone until you pass remove orphans yourself. This model is honest about its own ceiling, and the ceiling is one machine. Ask Compose to scale the API to 3, and you get 3 copies, all on that same machine, with nothing spreading traffic across them beyond DNS handing out addresses and no way to put one of them elsewhere. Recreating has a cost too, because Compose stops the old container before it starts the new one, so for a second or two, no API is running at all. That is fine on a laptop and unacceptable for anything serving real traffic. Then the command finishes and Compose is gone. If the API dies an hour later, the engine's restart policy is the only thing that reacts, and nothing checks the system against the file again until you run up yourself. The mechanism is sound. It just runs once, on one machine when you ask it to. If Kubernetes ever felt oddly familiar after learning Compose, this is why. The syntax changes and the scale changes, but the idea underneath is the same. Describe the system you want, compare it against what is actually running, change only what differs. That is reconciliation. And Compose is the smallest working version of it. A description, a label recording what was built from it, a hash to detect drift, and a converge step you can run as many times as you like. Compose compares the file to what is already running, once, when you ask. Kubernetes runs that same comparison continuously, forever, across every machine it owns. Same idea, running constantly instead of occasionally. If this is the kind of systems thinking you enjoy, the like button genuinely helps this channel, and subscribe so the next one finds you. See you then.